Today we'll discuss questions related to organic chemistry and mainly paper 4. But before this discussion, there is a small topic which is known as the homologous series. What is the meaning of homologous series? Any series of organic compound which is having the following characteristic is known as homologous series. And what are these characteristics? So any series of organic compound which is having the following characteristic, we call that as a homologous series. What are the characteristic of homologous series? Number one, there should be a general formula for the series. Like a general formula which can be used to find any of the member of the series. Number two, it should have same chemical properties. Every member will have the same chemical properties. Number three, each member differ by CH2, the difference between the members equal to CH2, like one carbon and two hydrogen. Physical properties for the series gradually changes. So the physical properties of the series gradually change, and we should have same method of preparation. So we should be able to prepare the member by the same method. So these are the characteristic of homologous series. So example, if we want to apply this for alkane, like we want to check alkane whether alkane is a homologous or no. So checking if alkane is a homologous, what is the first characteristic of a homologous series? It should have a general formula. And when we check alkanes have general formula. What is the general formula of alkane? It is CnH2n plus 2. So first tick for the same, like the general formula is there for the series. Like using this formula, we can find any member of this series. Same chemical properties, similar chemical properties, as you know, like when we are checking alkanes, for alkane, the property all alkane can burn, combustion is there. And the second thing, they have the substitution reaction. So alkanes undergo combustion and substitution, all alkane. Like example, if I have methane, I can burn methane, I can burn ethane, I can burn propane, butane, pentane, hexane, heptane, all of them can be burned. So they have the same chemical, and all can undergo substitution reaction with chlorine in the presence of ultraviolet light. Each member differ by CH2, means the difference between the members equal to CH2. So The first member of this series is CH4. The second member is C2H6. The third member is C3H8 propane. The fourth member is C4 and H10. So what is the difference between the members? The successive member CH4 and next is C2H4. So the difference is one carbon and two hydrogen. What is the difference between the two members? One carbon and two hydrogen. So one carbon and two hydrogen. So each member differ by CH2. So that is also a tick for alkane. Physical properties gradually changes. Physical properties refers to like melting point, boiling point, density. These are the physical properties. So as the number of the carbon increase, as there are more carbon, the boiling point will increase. Example, this is just a numbers. I'm just for explanation point of view, I'm using these numbers. These are not the actual boiling points. Example, if this was minus 30, then this is minus 15, then the other one will be like approximately 0, and the other one will be 15. So physical property gradually changes, like approximate difference is about 15. Approximate distance, I took exact, but it will be approximation. That physical properties gradually it is changing, so you can work out the missing value. Like if I say sometime you have to predict the boiling point. The first member is having a boiling point of say minus 60. The second member is minus 40. The third member we don't know, and the fourth member is about 2. What could be the boiling point of the third member? What could be the boiling point of the third member of this series? So it will be minus 20. So we can predict the physical properties, like because it's a similar change. It's not like exact minus 20 will be there. Minus for these type of questions, you will find a range of answer because some student might think might be minus 22. But that is how you can predict the boiling point of these organic compounds. So physical properties gradually change. That is tick also. Same method of preparation. How alkanes are formed by, we can extract these alkane by fraction distillation of the crude oil, and they are formed by the crude oil is forming, or crude oil which is a mixture of these alkanes. So they all have the same method of preparation. So all the five ticks for alkane. So what we can say? We can say alkane is a homologous series. Is it clear why alkane is a homologous series? Because it follow all the characteristic which belongs to homologous series. Is it clear? Same way we are checking whether alkene, or if alkene is a homologous. So first thing, the first point, they should have a journal formula. So the journal formula for alkene is CnH2n. So that is the first tick. They have same chemical properties. Alkene can burn, combustion can happen for alkene, as well as addition reaction can also happen for alkene. So the second tick is there. Each member differ by CH2. When I write the formula for the first member of alkene is ethene, not methane. So C2H4, C3H6, C4H8, C5H10. So when I take a difference, one carbon, two hydrogen. When I take a difference, one carbon, two hydrogen. When I take a difference, one carbon, two hydrogen. So each member differ by CH2. So that is also a tick. Physical property gradually changes, like the same idea is that, example, if this was minus 20, this is minus 10, then the other one might be like example 2, then the other one might be 13. So same similar physical trend is there. Same method of preparation, how we can prepare these alkene can be prepared by cracking of hydrocarbons. So all of these alkene can be made by cracking. So all the five ticks, so it means alkene is also a homologous series. So any series which follow these characteristics, we call that as homologous series. So important thing is you have to learn, memorize the properties of or general characteristics of homologous series. Same general formula, same chemical properties, physical property gradually change. Each member differ by CH2 and they all have the same method of preparation. Now we'll do some questions related to organic chemistry, alkane, alkene, alcohols, and carboxylic acids. The last part, the polymerization. The method of preparation, how we are preparing or how they are formed. The fossil fuel, all these fossil fuel, what they result or what it result in a formation of alkane. And how we form alkene? By cracking of alkanes. So when long chain alkanes are there, when we crack them, it will produce alkene. Like if you have C10 and H22, so it will break into, like example, C2H4 plus C8 and H18. So you can see alkene is produced, and this can produce any alkene. It is not necessary that C2H4, any alkene can be produced by this method. So they all have the same method of preparation. Is it clear? So the questions now related to organic chemistry, the topics. Now in the first question, petroleum is a source of many important chemicals. Name two industrial processes which must take place to produce alkene from petroleum. So petroleum, which is a crude oil. So from crude oil, how I can prepare alkene? Directly alkene cannot be prepared. Two processes are involved for formation of this alkene. What are the two? So first, fractional distillation, because when you do fraction distillation, it will separate the alkanes from each other. And then cracking, when you crack them, you will get these alkene. The next part, ethene, which is C2H4, propene, which is C3H6, both are converted into polymer. The term polymer means converting small molecules into long chain compound. What type of polymerization take place when ethene form a polymer? When alkene form a polymer, only polymer is formed, and what we call this type of polymerization? So we call that as addition polymerization. Addition means when we have, so this will result in a formation of addition polymer. So that will be addition polymerization because only one product is formed. What is the empirical formula of The polymer formed from ethene, the empirical formula is CH2, because empirical formula of monomer and polymer in addition polymer is same. So CH2 will be the empirical formula. Now, in this question, propene has a structural formula. The structural formula of propene is given. Draw two repeat unit of the polymer made from propene. But first thing, before drawing a polymer, we should rearrange the structure of a monomer. This is a monomer. So first thing what we should do, we should rearrange. So we should rearrange the structure to form a polymer. So rearrange the structure of a monomer, and your monomer should appear like letter H. So C double bonded with C. First make like this. Now what we do, these are the two carbon which are having a double bond. The first carbon is having two hydrogen, so one hydrogen up, one hydrogen down. The next carbon is having one hydrogen, so it is up to you, you can draw up or down. And next to that it is CH3, so there is CH3. Is it clear? I first rearrange the structure. This rearranging is not having a mark, but in exam first you should rearrange the monomer so that your monomer should appear like letter H. And then to draw a polymer, what we do, we draw the same structure but without a double bond. In the question they mentioned draw two repeat units, so I have to draw the molecule, the monomer twice because I need two units. Now what we'll do, we will break the double bond and put a bracket and write N. That is important. Bracket and N will give you 1 mark, and the structure of the monomer will give you the second mark. So that is why it is of 2 marks. Is it clear? The polymer which is formed by the propene, the name of this polymer will be polypropene. Any doubt in this? The next part, ethene will react with steam to form ethanol. So ethanol is formed. Propene react with steam to form two isomers. First thing, when propene react with steam, what will be the product? Propene plus steam. What will be the product? Alkenes undergo addition reaction, so only one product will be there. So only alcohol will be there. So propene plus steam will give propanol. That will be the only product. Because when alkene undergo a reaction with any reagent other than combustion, that will have only one product, so that will be alcohol. So when propene react with steam, it will form propanol. What we have to do, we have to suggest the structure of these alcohol. Propene react with steam to form two isomers means they have the same formula but different structure. So I have to draw two different structure of propanol. So first what I will do, prop means three carbons, so first I will draw three carbons. N means they will have a single bond. And in the first one, I will attach OH with the first carbon, then remaining hydrogen will be there. And in the second one, I will also draw three carbon, but now I will place OH with the second carbon. So they have two different structure. But for example, student and draw OH with another end. So that will be wrong. Why it will be wrong? Because these two structures are identical. When we are counting, here we are counting one from the left hand side, but when we count, we'll count one from right hand side. So it will be same structure. So if you draw OH with the first carbon, the next OH should be with the second carbon, not the other end. So these are the two structures, different structures form when when propene react with steam. When he says suggest the structure, so you have to draw the structure. Placing OH up and down, it will not make difference. That's right, it will not make difference. Like if OH is at the top, if I made OH down, that will not be an isomer. We should change the position. So when they're saying suggest the structure, basically you have to draw the structure. Because how you suggest a structure without drawing? So it should be draw the structure. This one is propanol and this one is propane 2 all. Is it clear? The two isomers of propanol. In the next part, ester are organic chemicals and noted for their characteristic smell. Like example, different artificial food colors as well as a distinctive smell is there. That is due to the esters. Ethanoic acid, ethanoic acid and methanol will react to form an ester. Name the catalyst needed to form an ester. So what is the catalyst? Yesterday we discussed this question. So we use sulfuric acid. So instead of in exam, you will not write H2SO4, it should be the name. So you will write sulfuric acid. Here, as you're answering a question, you can mention H2SO4, but in exam when you write this, it should be a sulfuric acid in words rather than a formula. The next part, name the ester formed when ethanoic acid react with methanol. What will be the name of ester? The first name is coming from alcohol and the second name is from carboxylic acid. So methanol plus ethanoic acid, this will result in a formation of methyl ethanoate. The first name of ester is coming from alcohol and the second name is from carboxylic acid. Then they are saying the next part, draw the structure of ester formed when ethanoic acid reacted with methanol and show all the bonds. So we have to draw the structure of methyl ethanoate. So first what we'll do, first we'll draw ester, which is C double bonded with O and O. That is ester. But this oxygen can be on the right hand side, it can be on the left hand side. That will not make difference to the ester. The part which is attached with oxygen is the branch, directly attached to oxygen is a branch. So meth means how many carbon I should draw with oxygen? So I should draw only one carbon. And eth means how many carbon should be there? Two. One is already there, so I will draw another one. Including this, there should be two. Then you have to show all the bonds, so this will have three hydrogen. And this will also have three hydrogen. So this is a structure of methyl ethanoate. Give the name of polyester, that part we will not do because that is related to condensation polymer. Another paper, this was May June 16. Now October November 16 paper. Petroleum is a mixture of hydrocarbons. It can be separated into useful fractions by fractional distillation. This can be done using a fractionating column shown. What happened to petroleum at X before it entered the fractionating column? Like before adding this to a fractionating column, what happened to petroleum? So it is heated. You can mention it is heated or it is vaporized or boiled. You can mention heated, that is correct. You can mention vaporized, evaporated. The next part, state two ways in which the fraction O differ from fraction L. So O and L, what will be the difference? O will be darker, that is one, that's right. The boiling point will be different, like which one have, you should mention which one have higher boiling point. O is more viscous, O is less volatile, L is more volatile. And you can compare the number of the carbon. O has having more carbon. You can mention O will be a larger molecule. It will have a higher boiling point, and O is less flammable because as the number of the carbon increase, it becomes difficult to burn. A complete combustion is difficult. If it is burned completely, as a result, it can give greater amount of energy. But combustion or burning is difficult thing for very long chain hydrocarbon. Like that is why for diesel engines, you will find the buses or the trucks, the volatility and boiling point are interrelated. So if you mention a point related to volatility, that is actually relating with the boiling point. In the next question, most of the most of the hydrocarbon obtained from petroleum are alkanes. The alkanes are an homologous series of saturated. The term saturated here does not mean it is water soluble. It means they have a carbon-carbon single bond. And unsaturated means they have carbon-carbon double bond. With the journal formula of CnH2n, give two characteristics other than having a same journal formula of a member of a homologous series. What could be the other property of a homologous series or the characteristic? Same method of formation, same chemical properties, same physical properties. So you can mention they have similar or same chemical properties. They will have same functional group as well. Physical properties show a trend or gradually changes. Each member differ by CH2 or they have the same method of preparation. So these are the things. Even same functional group. Same functional group also. There is one thing you can add to this, that they have the same functional group. Physical properties and same journal formula. Journal form other than journal formula is given, so that will not give you mark. They have similar chemical properties. Each member differ by CH2. Physical properties gradually changes. Same functional group. Same method of preparation. So you can write any two out of this. The reason why you cannot write a journal formula here, because it is already mentioned in the question that they have a journal formula, same journal formula. Other than this, you have to write. Another question, this is from May-June 2017, paper 4, variant 1. The alkenes and alkanes are both examples of a homologous series which are hydrocarbon. What is meant by the term hydrocarbon? So the term hydrocarbon means compound that contain only carbon and hydrogen only, or compounds having carbon and hydrogen only. One mark is for carbon and hydrogen and one mark is for writing a word only. And the three characteristics of homologous series that we already just discussed. So I just copy this, the previous answer. One more will be there. They have a same general formula, or there's a general formula for series. Next, name and draw the structure of second member of alkene. Second member of alkene. What is the which one is the second member of alkene series? So second member is propene. So name is propene because the first alkene started with ethene. So propene is the second member, and you have to draw the structure of propene. So C double bond, one of them will have double bond, another one single, and show all the bonds. So here you cannot write like this. Like if you write here CH2, you write CH and then CH3. That will be wrong. Why this will be wrong? Because this structure does not show all the bonds. In the question they say show all the atoms and all the bonds. So you have to show every bond. The first carbon, because two bonds are there, so two hydrogen. The second carbon, three bonds are there, so one hydrogen. And the third carbon, one bond is there with other carbon, so remaining three will be with hydrogen. So this is a structure of propene. Alcohols can be made from alkene. Which reagent and condition needed to convert alkene into alcohol? How we can convert alkene into alcohol? So reagent, reagent here refers to chemical. So we need steam, and what else? The condition, and using a catalyst. We normally use a phosphoric acid, so steam and phosphoric acid as a catalyst. Steam is the reagent, the chemical, and using phosphoric acid as a catalyst. And using a temperature, you can mention 300 to 350, or so using a high temperature and pressure. You can write the specific numbers as well, or you can just In general, you can write high temperature and pressure. Alcohol, a butanol, can be converted into carboxylic acid with 4 carbon atoms. Name a carboxylic acid formed by butanol and draw a structure. So if we oxidize alcohol, we can form carboxylic acid. So if it is butanol, which carboxylic acid will be formed by oxidation of alcohol? So it will form butanoic acid. And the structure of the butanoic acid, but means 4 carbons. So first I will draw 4 carbon atoms. Because of carboxylic acid, so it should be C double bonded with O and OH. And we have to show all the bonds. So this will have 2 hydrogen, and 3 hydrogen. So that is the structure of butanoic acid. The next part, ethanoic acid can be formed by ethanoic acid can be formed from ethanol by fermentation, because ethanol is formed by fermentation and then ethanol can be oxidized to form ethanoic acid. It can also be formed by addition of a suitable chemical reagent. Name a reagent needed to convert ethanol into ethanoic acid. So we have to add an oxidizing agent. So what reagent we need for this? So oxidation of alcohol, the reagent which we need, you will always mention acidified potassium manganate 7. Because acidified potassium manganate 7 is a better oxidizing agent as compared to potassium dichromate 6. That's why you will always find potassium manganate 7 is there. Potassium dichromate 6 can also be used, but for this specifically reason why we use potassium manganate 7 practically, because it is a good oxidizing agent as compared to potassium dichromate. Here potassium manganate 7 is better oxidizing agent as compared to dichromate. What type of reaction? This is called oxidation reaction, because it is addition of oxygen, so oxidation. Then the last part, it's of 5 marks. Describe how a student could prepare ester methyl ethanoate in a school lab. In your description, give the name, the essential condition, and chemical equation. This part I will discuss in the next session, because less than a minute left. So I'll share a link for the next session and continue this.